Draft physics video. Yeah. Anyway, thought I would respond to a comment by Rutger Blackhawk. Some more light theory Bell's theorem. I don't know, it doesn't say much about what his opinion is of this mush. But anyway, I thought it was worth conversation. Do a category for the message board on this whole light polarization thing, polarizing filters, I guess is come up with some other way to say it. So, Bell's theorem, the quantum Venn diagram paradox, it's this called minutephysics, so I guess I'll say something about they don't spend more than a minute's imagination, Anyway.
If you have polarized sunglasses, you have a quantum measurement device.
Each of these pieces
off from the first.
Whoops. Let's start over again.
Polarizing filter, which means when a photon of light...
Okay. So anyway, quantum measuring device. Why do they have to go to that extreme? It's just a mechanical device. All right? It's basically just lines. You can have the lines going this way, you can have the lines going this way. And it's just lines. Apparently these small enough lines you don't get diffraction anymore or something, but who knows. I have to think on that one. But anyway, we'll play some more of this.
Light reaches the glass, it either passes through or it doesn't. And whether or not it passes through is effectively a measurement of whether or not that photon is polarized in a given direction.
Try it.
Right, and polarized to them means some electromagnetical thing, which I think is unnecessary for. I mean, these are all assumptions that draw their image of the reality. So instead of just talking about what it's physically happening, they have all their assumptions built into it.
Find yourself several sets of polarized sunglasses or old photographic filters. Look through one set of sunglasses at some light source, like a lamp, then hold a second polarizing filter between you and the light. As you rotate that second filter, the lamp will look lighter and darker. It should look darkest when the second filter is oriented 90 degrees off from the...
Right. So yes, you can block all of the light if you block all the polarization. So I'll go to one of my diagrams here, since we're doing the instructional part. So it doesn't really, when you think about polarization, this is the same as that reversed. So you really don't have to worry about the 100 and the 360 of a circle. You just have to kind of think about the 180 degrees, because the reverses are impossible to distinguish from the... Anyway, you get the idea. This line would be impossible to distinguish from the reverse line here. To be the same angle, the same problem in getting through a filter. So you can just sort of ignore the bottom half and just go with this top. And so what's really happening with a polarized filter, say if we have it polarized straight up and down, then only light oriented on one of those angles would be able to get through. So if you thought about my frisbee analogy, which I think works, if you throw the frisbee on an angle, it gets through the bars. If you throw it flat, it doesn't get through the bars. So that's basically all the filter's doing. So there's only one kind of filter, it just means in how you turn the filter. But what's really happening is these are the photons that'll get through the filter if it's oriented this way. The red ones are the photons that won't get through. And obviously you put two filters, one going this way and one going lengthwise and one going crosswise, you would block all of the photons. Okay. Just how I would have explained it versus how they're explaining it, that's all.
First, what you're observing is that the photons with polarization that allows them to pass through a filter along one axis have a much lower probability of passing through a second filter along a perpendicular axis. In principle, zero probability.
Yeah, well, why even, like I said, so they're talking about a probability when well, obviously a frisbee thrown this way can't get through jail bars. So why talk about probability? It doesn't have anything to do with probability. It ain't going to happen.
But here's where things get quantumly bizarre. All these filters do is remove light. They filter it out. But if you take a...
So now that's another assumption they have, right? So he just said all these filters do is remove light. Now, there's no reason to say that. You know, it's why say the filters don't do anything else? If I throw frisbees at the jail bars, right? Now I could throw a frisbee that's at a pretty harsh angle, but it'll still might slide through because the filter will actually straighten the frisbee. The frisbee will hit the bar, bend a little, and then go through. So obviously the frisbees that hit in the right way, you know, and have not too much or too severe an angle, depends on how far apart the bars are, right? So if I make the bars just a little narrower than this, then almost anything can get through. But obviously that's not what we're talking about. They're a little tighter than that. But the point would be is that the filter does have an effect. It isn't free. It isn't just a filter that says we're going to block stuff. It's a filter that can affect the stuff going through the filter. That is, it can bend it a little. And this whole video would be unnecessary, and all this quantum woo would be unnecessary if they just said, yeah, maybe that's a possibility. That's the hidden variable. See, they call that a hidden variable. You know, the idea of an actual cause. That they give it the mysterious, you know, when you identify the actual cause, you've identified the hidden variable. You know, they have to give it a mystery kind of identity because, you know, they're selling this woo.
Third filter and orient it 45 degrees off from that first one, and then you put it in between the two, the lamp actually looks brighter. This is not the middle filter generating more light. Somehow, introducing another filter actually lets more light through. With
Right, so, well, I guess we'll just play this.
perfect filters, if you keep adding more and more in between at in-between angles, this trend actually continues. More.
Right, so you get somehow, right, as you turn the filter a little at a time, somehow that gives you more than if you just turn it all the way right away. So if you go at a 45-degree angle, you'll get half the light removed. Where if you go at a 22-degree angle and then another 22 degrees to get to the same 45 pretty much, you'll end up with more light this way than you end up with this way, getting through. Now, to me, the obvious conclusion is, the filter is affecting the light, and it's a simple effect. Like I said, I can use my frisbee analogy and you know, answer the question, why does that happen? Well, because when the light goes through the filter, this is the stuff when you have it straight up and down. The light goes through all these angles of frisbee throw. You know, I gotta do that further away. Yeah, all these angles make it through the filter. And the harshest ones, the ones the most off, let's just say they're improved by 7% or 10% even. Okay, or we could even say proportionally every one that goes through gets tightened. So it's just that this arc, this 90 degrees of black here, turns into 70 degrees when it goes in. So there's only 70 degrees of divergence after it goes through the filter. So it has 90 degrees here, and let's say 70 degrees here. And that will produce this result where now when you put the second filter going this way, you'll be able to, let's say the two things we're comparing is this 22 degrees filter versus a 45 degree. So if you put it at 45 degrees from here, from this pattern, what you're going to end up doing, 45 would be here, well, that would include all these that didn't get through the first filter. So it would let through light that didn't get through the first filter, but it can't let through light now. See, so this 90-degree arc still stands. So it would have let through this light, but that light never got through the first filter. So the only light it can let through is this. And this happens to be 50% of the light total that got through the first filter. So you only get, if you use the 45-degree angle, you only get 50%. Okay? Because all you can get is this. And this side can't get through because it's too far away. I mean, it's too big an angle difference, so it can't get through. And then when this 50% gets through, it gets improved a little. So now, you know, this worst line here gets bent more like this. So now it's improved a little. It's a little tighter. So, but anyway, so the 45 would get you 50. Now let's say you use this 22 degree angle. Well, now you'll get all of this side plus most of this side. And all you're going to lose is this. So this would be the 15% you lose. Would be the stuff that's still too far out from the 90 degrees from this 22 degree point. So it's 45 degrees this way and 45 degrees this way. So from 22 degrees, which is somewhere in here, you're gonna. This is the 45 degrees you can keep, and the 45 this way. Obviously, this way doesn't do you any good because none of this light got through. But you keep all of this side plus most of this side, and all you lose is this 15%. So this filter, you only lose 15%, and when you apply the same filter again, going another 15%, all you're going to lose is 15% of your new arrangement. So that explains why if you apply the filters in increments, you'll be able to preserve more light, because with each filter you're not only excluding some light, but you're also compressing the band, and therefore the next filter will be more effective. So you're improving the you're tightening it, you know, so more stuff will be more easily included, because with each filter you're tightening this band a little bit. So anyway, so that explains it. I mean, it's a perfectly viable explanation, and so they spend the rest of this video talking as if this is impossible to explain. There's can't be an explanation. There can't be a hidden variable or cause, you know, and you know, because what? They didn't spend 5 minutes thinking about it. As far as I'm concerned, it took me 5 minutes a couple of years ago to come up with that answer. So, you know, and I haven't found any reason why it's not a perfectly viable answer to this paradox. Oh shit, I didn't want to do that. Well, I certainly don't want this advertisement. That's really annoying. They must have did that. It's not my fault they did it. Creeps.
Or light.
This feels super weird, but it's not just weird that more light comes through. When you dig in quantitatively to exactly how much more light comes through, the numbers don't just seem too high, they seem impossibly high. And when we...
So it's weird and it's impossible, and you know, oh, it's got to be the magical quantum world. Ooh.
we tug at this thread, it leads to an experiment a little more sophisticated than this sunglasses demo that forces us to question some very basic assumptions we have about the way the universe works.
Right. So that's you know, this dogma that we have to be perplexed and we have to question our whole understanding of a material physical universe, and then we're going to use their silly jargon. You know, oh, there's a thing called realism, and then there's a thing called local fakery. I mean, it's just, you know, that's their bullshit terminology, right? There's either an accurate description of a mechanism or an inaccurate one. That's all there is. So yeah, there's getting it right and there's getting it wrong. Right answers and wrong answers. That's all there is. There's none of this bullshit.
Like that the results of experiments describe properties of the thing you're experimenting on, and that cause and effect don't travel fast.
Yes, and it's absolutely stupid to think that your experiments are so explicit, and that you understand every single mechanism and what every single mechanism is doing, that therefore you can draw these hard conclusions, when we know that every experiment we do sort of fucks with the thing we're trying to measure. It's really hard to measure something without, in one way or another, fucking with its environment. And that's a truth. And clearly a polarizing filter can be fucking with the photons. It doesn't just filter them. It cleans them. It manipulates them. Yeah.
Faster than the speed of light. These will come into question.
Where we're headed.
So we're going to come into question the speed of light, because now they're going to do all their little entanglement nonsense. I mean, it just, you know, just for one reason, because they can't accept that there could be a physical explanation for why there's a difference in filters. You know, why there's a difference in results depending on how you apply filters, because the filters are actually affecting the photons. The filters are actually affecting the photons. That's the simple truth. They won't even consider it as something that could be possible. The filters actually affect the photons. Let's not even consider that.
It is Bell's theorem, one of the most thought-provoking discoveries in modern physics. And
says them again. So they think this idiotic theorem, frankly, I don't see how it's so compelling. You know, basically defining the rules of probability, you know, in a sense. I mean, I don't find it earth-shattering in any way.
To appreciate it, I really do think it's worth understanding a little of the math that we use to represent quantum states, like the polarization of a photon. And
yes, well, you can't understand any of that math, so thanks. But yeah, they're not going to explain any of the math.
Actually made a second video showing more of the details for how this works, which you can find on 3 Blue 1 Brown.
Yeah, it says how it works. So again, it's how you say it works, because you say it's all doing this wavy crap. You know, and that photons couldn't just be a solid thing that has a shape, like a frisbee.
But right now, let's just go ahead and hit the main points. First, photons are waves. Waves in a thing...
Right, so says them, right? They're going to just keep saying, this is what they are. We've all agreed this is what they are. You can't believe there could be anything else. They have to be this kind of thing. They have to be waving in some non-medium, right? So again, the question is, waving in what? So they're waving in two different fields of nothing. An undescribable place where things can vibrate the stuff in the place. Yeah, sure.
Called the electromagnetic field. And polarization just means the direction in which that wave is wiggling. Polarizing filters...
yeah, and again, there's no hard reason to believe this. There's a fact that polarization happens, that the thing has some kind of difference between photon polarized one way and photon polarized another way. But there's no evidence indicating that polarization has to be anything other than the photons are dimensionally different. That's all. Their orientation is different. Nothing more.
Absorb this wiggling energy along one direction so that the wave coming out on the other side is wiggling purely in the direction perpendicular to the one where the energy absorption is happening. But unlike a water wave or a sound wave...
Yeah, well, this energy absorption thing doesn't happen, and like he's going to have to say that right now. He's probably going to say something like, yeah, but photons don't do that. They don't. You can't absorb its magnetic part. You can't absorb just its electric part. You can't absorb part of the wave. So it's just meaningless mush, because you know, even as Feynman would point out, yeah, first it's a corpuscle, first it's a particle, and that's just a fact. And then okay, we can accept that it functions wave-like, but it is quantizable and it only reacts completely. It doesn't react partially in any wave-like manner.
Photons are quantum objects, and as such, they either pass through the polarizer completely or not at all.
Right, so what was all the point of that whole energy releasing or energy absorption in one of these dimensions? Because it can't do any of that. It can't have its electrical component absorbed and not its magnetic component. So it's just meaningless.
And this is apparently probabilistic, like how we don't know...
So again, it's apparently probabilistic. So at least it says it's apparently. But probabilistic means what? That there's an environmental circumstance that confines outcomes. Yeah. Every time there's an environmental circumstance that confines outcomes, that means there's a probability. It's like I could spit in the air and there'd be a probability that I can make it land on this magnifying glass. So what? We know that it's a physical event, that there's no quantum involved. The probability is going to be based on how good a spitter I am.
whether or not Schrodinger's cat will be alive or dead until we look into the box.
For anyone uncomfortable with the non-determinism of quantum mechanics, it's tempting to imagine that a probabilistic event like this might have some deeper cause that we just don't know yet.
Yeah, so it's tempting to think rationally, but don't do that, because no, we're going to demonstrate that rational thinking can't possibly work, because they don't have any imagination.
That there's some hidden variable describing the photon's state that would tell us with certainty.
So again, hidden variable that would tell us the photon's state. We don't need to know its state. We don't need to have it tell us its state. All we have to do is have an open enough mind to say, oh, the filter isn't a quantum measuring device after all. Okay, it's a filter. It confines, it creates a confinement in the environment, and that confinement causes effects to the actual photons. That it doesn't just do quantum measurements, it changes the photons. But no, we're not allowed to do that. Then that's a hidden variable. Just a rational understanding like that, that your measuring device might be affecting the photons. That's, we need to go to some special hidden variable dimension to get that answer.
Whether it should pass through a given filter or not. And maybe that variable is just too subtle for us to probe without deeper theories and better measuring devices.
So it's too, no, we can't possibly speculate and come up with an answer. We can't possibly just think, like I said, just understand that the variable, all is required for this variable to do is to affect photons. That's it. And they just didn't bother thinking that was possible. It's not possible that the filter affects the photons.
Or maybe it's somehow fundamentally unknowable, but still there.
Unknowable. Mystery, mystery. No, it's not mysterious. Whoops.
The possibility of such a hidden variable seems beyond the scope of experiment. I mean, what measurements could possibly probe at a deeper explanation that might or might not exist?
What? So again, so all this, well, how can we possibly imagine anything? How can we possibly come up with any answer to how this weird result takes place? We can't possibly consider that the polarizing filter is actually screwing with the photons.
And yet, we can do just that.
With sunglasses and polarization of light. Let's go ahead and lay down some numbers here. When light passes through a polarizing filter, oriented vertically, and then comes to another polarizing filter, oriented that same way, experiments show that it's essentially guaranteed to make it through that second filter.
Okay, now this isn't even true. That 0% gets blocked, that 100% passes. That's an idealistic thing. Okay, somebody will theorize that, yes, it's theoretically possible that you could make a filter that would pass 100. It's theoretical possible you could make a combustion engine that's 100% efficient, but it's only theoretically possible. It's not in any way practically possible, not even close, because we don't have some mechanism to turn the heat back into fuel or do anything like that. So the filters are going to block some percentage. Now that percentage could be 2% or something. It's not could be a low percentage depending on the quality of the filter. But, as I pointed out in the past about even throwing frisbees at jail bars, sometimes you throw the frisbee the right way, but it hits the jail bar, it hits the bar and bounces off. So it doesn't get through just because it was going the right way, but it hit the bar. And, so, it's just a false axiom. So they're setting up premises and they can't get the premises right. I mean, at least not accurate to practical reality. There's no 100% pass filter. It doesn't exist.
But if that second filter was tilted 90 degrees from the first, then each photon has a 0% chance of passing through. And
right, so they already said this part before, but yeah, obviously if I turn the jail bars this way, and I'm throwing frisbees this way, not going to get through.
halfway between, at 45 degrees, there's a 50-50 chance.
What's more, these probabilities seem to only depend on the angle between the two filters in question, and not on anything that happened to the photon before, including...
not anything that happened to the photon before. So again, what would be happening to the photon before, where the whole, I mean, that's almost kind of a silly way to say it. They're almost saying like, well, it doesn't have anything to do with the photons here. But clearly it has something to do with the photons here. So when they go through this filter, they're different photons, subtly different, and that's why they pass through the next filter more efficiently.
Potentially having passed through a different filter first.
But the real numerical weirdness here happens for filters oriented less than 45 degrees apart. For example, at 22.5 degrees, any photon which passes through that first filter has an 85% chance of passing through the second filter.
Right. So now we're up to we got 85%, so it's only 15% loss. And then you put two of those together, you got 45 degrees, and you only have a 30% loss versus a 50% loss here. And so that's the paradox. And again, I'll just reiterate, the paradox is solved by just saying that there's, when the light passes through the filter, the worst offenders, you could even just argue, these ones that are the most angularly off are the most dicey to getting through, the least vertical. They're improved in their condition. So this fan is tightened, and that tightening solves the paradox.
To see where all these numbers come from, by the way, check out the second video.
What's strange about that last number is that you might expect it to be more like halfway between 50% and 100%, since 22.5 degrees is halfway between 0 and 45, but 85% is significantly higher. To see concretely...
Well, it's only 10% higher, but you can call that significant if you wish.
How strange this is, let's look at a particular arrangement of our three filters. A, oriented vertically, B, oriented 22.5 degrees from vertical, and C, oriented 45 degrees from vertical. We're going to compare just how many photons get blocked when B isn't there with how many get blocked when B is there. When B is not there, half of those passing through A get blocked at C.
Right, we've already done this, thank you, for the third time.
That is, filter C makes the lamp look half as bright as it would with just filter A. But once you insert B, 85% of those passing through A pass through B, which means...
Yes, so again, the point is that when they went through this filter, this got tightened. So then when they go through the next filter, there's less cut off because they're tighter. So this isn't a very good drawing because they don't have these centered, right? I mean, you could visualize it better if they centered this and then centered this, you know, because that's more realistic. I mean, this is the way it works, okay? It's not like half and half this way. The truth is the half is, this fan is half, and then these two fans add up to half, you know, 90 degrees. And that's the way it really works. And so you have to kind of think of it in a center argument kind of way. And so again, 50%, if you go 45 degrees, you'll kill 50% of the tighter fan. But it still ends up being 50% unless you do this first. If you do this first, then you'll tighten, you'll lose this, but you'll keep all of this, and you'll tighten it. So like I said, all it has to do is be like a 7% improvement. So the polarizing filter just improves the verticalness by 7%. And that's all you need to fix the paradox.
15% are blocked at B, and 15% of those that pass through B are blocked at C. But how on earth does blocking 15% twice add up to the 50% blocked if B isn't there?
You know, why didn't you just say, so that's only 30% being blocked, and there's 50% blocked when you go with the 45 degree angle first. So if you don't incrementally change, then you have a difference between 50% and 30%. Yes, and that's 20%, so it's a 20% difference, which is significant. Yes.
Well, it doesn't, which is why the lamp looks a lot brighter when you insert filter B. But it really makes you wonder how the universe is deciding which photons to let through and which ones to block.
How the universe is deciding. See, they just got to keep making it sound like it's, you know, some sort of wizard story.
In fact, these numbers suggest that it's impossible for there to be some hidden variable.
Okay, so it suggests that it's impossible to consider that the experiment, the filter, could be affecting the photons. It's impossible.
Determining each photon's state with respect to each filter. In other words, it suggests that it's not even possible for these photons to have some definite answer to the three questions: would it pass through A, would it pass through B, and would it pass through C, before those measurements are actually made.
So this, I'm not going to play the rest of this, but it's all Venn diagrams. So the whole point of this is to say there can't be an effect. So they're just using these diagrams, basically saying the filter can't change the circumstance, and so if you can't allow the filter to cause any effect, then yes, it won't work. It can't make sense because they already pointed out how it can't make sense because the two different filter arrangements come up with different numbers. So the filters have to be affecting the photons. I mean, it's just logical to recognize that must be the answer. And I don't think it's logical to bury themselves in this woo. All right, well, let's play a little more.
What we'll do here is a proof by contradiction. Imagine 100...
Yeah, a proof by contradiction, which is a proof by, well, we're just going to ignore the possibility that the filters affect anything. And then we're going to say, there, we've proven that a hidden variable, an effect by the filter, is impossible, when they didn't even consider it. And their Venn diagrams don't have it in it. There's nothing in the Venn diagram that makes it possible to consider an effect that happens while you get your result. So you have your result, which is 85% get through, and you're just ignoring the fact that that 85% is in a different configuration than it was before it went through.
Photons who do have some hidden variable, which through whatever crazy underlying mechanism you might imagine, determines their answer.
Okay, so now they're saying we have to think the photons before they even got to the filter were deciding to be screwed up or something. So the hidden variable can't be the filter. The hidden variable has to be way, way before the photons even got to the filter. So they're not even recognizing that, no, the filter could be the hidden variable. I don't need the photon to have some magic powers before it got to the filter. The filter imposed the effect. Just like the two slits, okay, caused the effect of the pattern, not the photons.
To these questions. And let's say that all of these definitely pass through A, which I'll show by putting all 100 inside this circle, representing photons that pass through A. Now, if you want to produce the results that you see in experiments, about 85 of these photons would have a hidden variable determining that they pass through B. So let's put 85 of these guys inside the intersection of circles A and B, leaving 15 in this crescent moon section representing photons that pass through A.
Right, so B represents the 22-degree angle thing. He didn't say that, but that's what B is representing. So at 22% you lose just this one, like I said, you lose this one line, but you keep all of these. So you keep the 85%, but you lose the ones that are this way. But you keep everything that's this way all the way to the 45. I mean the 22.
A, but get blocked at B. Similarly, among those 85 that would pass through B, about 15% of them should get blocked at C, which is represented in this little section here. That's in.
Right, so that's another 22% filter. So I don't know why they don't call these things what they are. So this is the straight up and down filter. This is a 22%, 22-degree angle change, and then this one's another 22-degree angle change.
Inside circle A and B, but outside circle C. So the actual number whose hidden variable has them passing through both A and B, but not C, is certainly no more than 15.
Right, so this gets so convoluted, forget it. So they're saying the photons have the hidden variable. Not the filters, the photons. So that's where this is hopeless. Alright, I don't know if there's anything, I don't think there's anything, they just keep doing this Venn diagram thing like they're somehow explaining something that really doesn't explain shit. Oh, they do get into entanglement, though. I guess I should get to that somewhere here. You know, that they've somehow done these magical experiments that demonstrate something. And they really haven't. Let's see what this little gibberish here means.
Violate Bell inequalities in exactly this way. John Bell originally put out the inequalities and the observation that quantum mechanics would violate them in 1964.
Since then, numerous experiments have put it into practice, but it turns out it's quite difficult to get all your entangled particles and detectors to behave just right, which can mean observed violations of this inequality might end up with certain loopholes that might leave room for locality and realism to both be true. But the first loophole...
So again, you know, we have to accept their notions that there's these two competing things called locality and realism. You know, that one of them has to be right and one of them has to be wrong and all this other bullshit. So anyway, I'm not going to even bother with that because, again, the whole thing is premised on false assumptions regarding how polarizing filters work. And if those assumptions are wrong, then all of these conclusions are useless. All these experiments are useless. If they don't understand that the filter is actually changing the photons, then they're not going to get the right answer. They're going to go searching for the right answer and some more wrong assumptions. So I think that's probably enough. Yeah, I think I've made the point that there's no paradox if you allow the filters to affect the photons, to be causing an effect. Then there's no paradox.